Hello, and today's purpose of the day is I can solve a system of equations using the elimination method and review all ways of solving systems, including writing systems. I can also simplify radicals. Review. When solving a system of equations, what are the three possible outcomes you can get for answers? You got it! Infinitely many solutions, no solution, or one solution. So let's take a look at the three possible outcomes a little bit more in depth. The first one would be if we have no solution, so we have two lines that are parallel that never touch, and that would be described as inconsistent. The second option is if you actually have two lines that are the same line, and that would be infinitely many solutions and we would describe that by saying consistent and dependent. And the last possible scenario is if we have a graph and the two lines intersect exactly one time, we would have one solution be where the two intersect, and that would be called consistent and independent. The next method we are going to look at to solve a system of equations is the elimination method. So we want to use this when both equations are in standard form. We want to write equations with the same or opposite coefficients to be aligned. We want to write or subtract equations to eliminate a variable, hence the word elimination in the title. We'll solve for a variable and substitute that answer in to find the other coordinate point. So let's look at example number 1. 4x plus 6y equals 32 and 3x minus 6y equals 3. So if we have opposite signs here, like 6y and negative 6y, those are obviously lined up. We want to go ahead and add the two equations. Whoops. And when I add the two, 4 plus 3x gives me 7x. The y's cancel out, and I get 7x equals 35. Now this is very simple because I can just solve for x, and I can divide by 7 and get x equals 5. But this is only half my answer. I need to plug that back in order to find my y variable. So whichever equation perhaps looks easier, I would plug in 5 for x for. So I would do that to maybe the second equation and get 3 times 5 minus 6y equals 3, and get 15 minus 6y equals 3. Subtract 15 and get negative 6y equals negative 12. Divide by negative 6, and that's a negative right there, and get y equals 2. So my final answer here, if I write this in ordered pair form, would be 5, 2. And again, we want to use the elimination method when we have our equations in standard form, and I can easily cancel out a certain variable. Let's take a look at the second example. Here I have negative 4x plus 3y equals negative 3 and 4x minus 5y equals 5. So again, I can see that I have negative 4x and positive 4x, so I want to go ahead and add those two so that they will cancel out, and then I will get 3y plus a negative 5y, which would be negative 2y equals 2. Divide by negative 2, so y equals negative 1. Now I want to go ahead and plug that in for whichever equation perhaps looks easier, which I think will be the second equation. So I'll plug in a negative 1 for y and get 4x plus 5 equals 5. Subtract 5 and get 4x equals 0. So here x equals 0, so my final solution will be 0, negative 1. And again, if I plug in that solution to both equations and for x and y, it should work out and it should fit because it is the solution to this system. There may be times when using the elimination method that we have to multiply both equations by a number because the variables and the numbers with those variables don't line up. For example, here we see 5x plus 6y equals negative 8 and 2x plus 3y equals negative 5. So none of the variables and the numbers in front of them actually line up. So let's change one of the equations to line up with the other one. So I'm going to multiply the second equation by -2, so I can line up my y variable. So now this changes. This first equation stays the same, but now the second equation changes to a -4x, a -6y, and I accidentally wrote x twice, equals 10. Now I would go ahead and I would add the two together so that the y's can cancel out. And then 5x plus -4x is x, equals -8 plus 10 is 2. So x equals 2. Now I would plug that in for whichever equation perhaps looks easier. And so, I don't know, I would plug that maybe just into the second one and get 2 times 2 plus 3y equals -5. 4 plus 3y equals -5. Subtract 4. 3y equals -9. Divide by 3. Y equals -3. So my final solution here would be 2, -3. Let's take a look at a few word problems when we need to write a system of equations given a word problem. So the first one, let's zoom in here. -3 times one number plus 5 times another number is -11. Before I move on, I'm going to write a system or an equation for the first part of my system from that first sentence. So -3 times one number, which I'll call x, plus 5 times another number is -11. So again, I'm translating those words into numbers and symbols. And then the second sentence will go with the second equation. 3 times the first number plus 7 times the second, or times the other number, I should say, is -1. Find the numbers. So now this is easy because I already have numbers with variables that line up. So I will go ahead and add the 2, and this will cancel out. 5 plus 7y is 12y. -11 plus -1 is -12. Divide by 12, y equals -1. I could go ahead and find y here, and I'll say 3x plus 7 times -1 equals -1. Add 7, 3x equals 6, so x equals 2. So 2, -1 is my solution. Let's take a look at the second example. Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. During a typical week, Cheryl and Jackie earn $299.50 together. One week, Jackie doubles her work hours and the girls earn $412. How many hours does each girl work during a typical week? Well, let's practice writing equations here for each sentence. So I'm going to highlight where I'm going to write my first equation from. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. So if I translate that into an equation, that would represent 8.50 times Cheryl, because that's how much she earns, plus 7.50, Jackie's hourly wage. And together, they earn, I probably should have highlighted this, $299.50. So $299.50. So I can write one equation with that information. Now, the second equation will come from the 1 week, Jackie doubles her work hours and the girls earn $412. So I can rewrite that into saying, okay, $8.50 is still Cheryl's wage for working at that store. And then now if Jackie doubles her hours, not $7.50 anymore, but it's going to be $15, together they will earn $412. And so now I want to solve this here. So I actually can subtract because then the C variables will cancel out. And 750 minus 15 will be negative 750J equals 299.50 minus 412 is negative 112.50. Divide by negative 750 and get J then is equal to 15 hours is what she will work. And then if I plug that back in, which I'm just going to save a little bit of time because we've already done a few examples, then Cheryl would be working 22 hours. So again, this was a word problem. It had a little bit more going on that we had to really look at and break down, but we can still easily solve that. Now we're going to take a look at simplifying square roots. So if you could please add this to your notes, that would be fantastic. And let's recap. So the radical is in simplest form if no radicals have perfect square factors other than 1. So this, again, just to recap, imperfect squares are like the square root of 4, because that is 2. The square root of 9, because that equals 3. Square root of 16, because that's 4. Square root of 25 is 5, and so on and so forth. So let's take a look at a few examples. The square root of 52. I want to look for the largest perfect square in 52, which would be 4, and then its pair is 13, and the square root of 4 is 2, so out comes a 2, but the 13 stays underneath. So my final answer is 2 square roots of 13. Now if I look at number 2 though, I already have a 4 outside, so whatever I break down of 24 and take out will be multiplied by that 4. So the largest perfect square into 24 will be 4 and 6. Square root of 4 is 2, but I already have a 4 out in front, so 4 times 2 is 8 square roots of 6. And even though 6 breaks down to 2 and 3, that won't really help us because are either one of those two perfect squares? No, so it doesn't get us anywhere. Number 3, 6 times the square root of 375. Take some time to work on that one. Nice job. You can break down the 375 to 25 and 15. And out comes a 5, but you already have a 6, so that becomes 30 square roots of 15. Okay, let's look at number 4. Number 4 has now variables, so we have to remember what we do with variables. So let's break this down first, just with the 45, and then we'll worry about the variables. So 45 breaks down into 9 and 5. Square root of 9 is 3, but 5 still stays under. So now let's go ahead and look at the variables. So 8 to the 4th is even, so you can just, slice that variable or that exponent in half and just take out an a squared, because a squared times a squared equals a to the 4th. You add exponents with the same base. Now if I look at b to the 5th, this is not even, so I have to break it down to something that is even, b to the 4th and just b. And then which one of those can I cut in half? The even one, so out comes a b squared, but b still stays underneath the radical. And last but not least, c to the 6th is even, so I can just take out a c cubed. So everything that's circled will come outside the radical. Everything that's not will obviously stay underneath. So a 3 comes outside, an a squared, a b squared, and a c cubed times the square root of, I'm going to erase this to get out of the way, times the square root of 5, and then b is still left under the radical. So that would be my final answer. All right, last example, square root of 264 times x cubed y cubed. If I break down 264, I'm going to break that down into 4 and 66. Square root of 4 is a 2. And 66 breaks down into, 6 and 11? But that won't really help us because neither of those are perfect squares. So that would be it. And if I break down x cubed into x squared and x, out would come just 1x, and then y squared, square root of that would just be y, so my final answer here would be 2xy times the square root of 66x, and that would be my final answer for number 5. Thank you for listening. Please see Schoology for more information. Have a great day. Bye.